Hi again and welcome. Since the last video cut off this part of the kinematics equation example, I'm going to redo it out. So in this problem, it's not a plug and chug because there's more going on than just, one motion. If we read our problem, we find that the car is actually doing three types of motion. So just give me 1 second as I load up my pen here. Okay, we'll use this, why not? So notice that we have a rocket sled and it accelerates at 50 meters per second for 5 seconds, coasts for 3 seconds, then deploys a braking parachute and decelerates for 3 meters per second squared until coming to a halt. So as you can see already, I diagrammed what's happening. So for part of the motion, we are accelerating, and then the next part we're coasting, which means we're no longer pressing the gas, if you think of it that way. So then we have no acceleration. And then that happens for 3 seconds, so this is this section. And then lastly, we have this section right here where it decelerates. So that means we're going to be slowing down. So our acceleration must go opposite our motion, which is why we have a negative sign right here. And since it's coming to a halt, we're going to assume that this is 0 right here. So that's our problem, and we're going to figure out the maximum velocity of the sled and then how far it went. So kind of analyzing the situation, you'll find that our maximum velocity basically happens here because we start from rest, we go up to a certain velocity, then we maintain that velocity, and then we come to rest again. So essentially, if I find this, I could find our maximum velocity. So I will do that. Here we go, part A. So I'm going to use this section. So let's list the information we have for that section. We have a 0 initial velocity, a time of 5 seconds, an acceleration of 50 meters per second squared, and we are looking for our final velocity, how fast we're going. So if you take a look at your kinematic equations, the best one that suits this would be this. And as you can see, we have, we're looking for VF, we have VI, A, and T. So this will help us solve for that problem right there, so the final velocity. So our initial is 0 plus A, which is 50 meters per second squared, multiplied by the time it takes to do this, which I believe is 5 seconds. So our final velocity and maximum velocity, therefore, is 250 meters per second. Now, noting the sign of this, notice that this is positive, meaning it's moving forward. So, and that's what's happening in this case. So that's a good check, is to take a look at that. So that is that's our maximum velocity. That one was pretty simple. Well, not simple. I'll say straightforward. Okay. However, this next question is not simple because we have 3 different motions. So it's always important to break down the problem, especially if you have different types of motion. Breakdown problem into separate motions. So that's how you're going to analyze this. You can't do this all in one equation because there's too much going on. There's different things happening at different times. And you need one equation for motion for every type of motion. So what I'm going to do is break this down into 3 parts. So I'm going to call this part 1 and find the distance there. Part 2 and find our distance there. And part 3. So we're going to have 3 different distances, and as you can see, the question is the total distance. So total distance is going to be the sum of the 3 distances that I get from this problem. Like that. So this is a very important problem. This is a good type of AP problem, a good college problem, because there's not just a plug and chug situation. Okay, so let's go ahead and do that. So I'll do my best to try to keep the problem in sight, or at least refer to it. So let's start with part 1. Actually, I'll do distance 1 right next to the information because this is all referring to the first part anyway. So to find the distance 1, the information we have is we have the initial velocity, we have time, and by the way, absolutely take shortcuts. I'm just redoing it just to be thorough, but naturally you have all this information already, so you can just use it from before. And the neat thing is now we have a final velocity here. So we have initial, time, acceleration, velocity. Quite technically, because of all the information we have, we can use any of the kinematic equations that have the information we want, which is delta x, right? So I mean, this is personally, I am going to pick, since there's multiple choices, I'll use this one. Now I picked this one because it simplifies quite nicely, actually. Since the initial velocity is 0, this whole term drops out, because 0 times any number will give us 0. So this now becomes 1/2 at squared, just like that. So this will give us the distance it goes, starting from rest. And with that said, I can plug in my numbers. So I get 1/2 a, which is 50 meters per second squared, times 5 seconds squared. Just because I'm running out of the room, I'm just going to write this answer up here, so I apologize for that, but I'm just getting my calculator. I'm going to calculate that out. So 0.5 times 50 times 5 squared. So I get a total distance at location number 1 of 625 meters. That sounds about right. Very good. So essentially, I just repeat this another 2 times for each part. So the second distance, that's constant velocity, and the key word is coasting. We're not adding any sort of acceleration or gas, if you will, if it's a rocket car, during that section. Constant speed, velocity. I'm interchanging those lines right now. But because that's the case, then we can use the constant velocity equation. Velocity is distance over time, or displacement in this case. So I actually know the velocity that we're maintaining at that point. Remember, that's the final velocity from before. So that's the 250 meters per second. And the problem does tell us how long it's been doing that for. It's really nice that the problem is 3 seconds. Okay, so let's go down. Time is equal to 3 seconds. The question is, basically, I'm going to just put the symbol here just for the second part, is what is our distance at that point? So there we go. So it's going to be velocity over time. I'm sorry, velocity is distance over time. So I'm going to plug in my numbers. So this is the variable. This is the time, 3 seconds. And this is 250, right? And that's meters per second. When I multiply both sides by 3, I'll solve the problem. So when I do that, I know what it is, but I like to check, because I don't like to officially assume. Okay, but I was right. So 750 meters, like that. So I'm just going to box that because I'm going to need that for later. So notice that I box my answers just sometimes because, like I said, I'm going to need them for later. So far we have that this is 625 meters. We have that this is 750 meters. Now we're going to calculate this section. So since we're maintaining our speed, the velocity here is going to be 250 meters per second. So this will now become an initial velocity because I'm starting here. And you could do that. Just because the problem started here doesn't mean I have to go over here. You can pick your starting point anywhere. And that's really helpful, especially for a problem like this, to pick it right here. So I will do that because you can. You can start it anywhere. And I know that my final velocity is going to be 0 and I have an acceleration. So let's go ahead. Maybe I'll go to the side here so we can see the diagram so it's helpful. To calculate the distance in part 3, what we're going to do is we're going to list our information. So I have an initial velocity of 250 meters per second. I have a final velocity of 0. I have an acceleration as -3 meters per second squared. And then that's all I have, and I have to find delta x. And I'll put 3. And just the 3 just means I'm talking about this section right here. You too. Take care. Sorry about that. Okay. So what I'm going to do is, saying goodbye to a colleague, is pick out the equation that has the information I need. And I know this is going to take you time. So, don't be alarmed that I'm just like thinking of this. This is, of course, because I have experience. You're still going to need some time to figure out and go through each of those 4 equations. But when you do, kind of like after you chop all your onions, this is what you get. This is the equation you'll find that is most helpful because we have all the information here. Now we don't have time. Notice that time is not given, so that wouldn't be helpful. Okay, so with that said, we're going to do the following. Plug that in. This is going to be a big number, as you can see, right? So this is going to be squared for the initial, plus 2 negative, because we're slowing down, so our acceleration must be opposite, times delta x. Sorry about that.
Mariah Toles, your ride is here. Mariah Toles, your ride is here.
There you go. Beauty of working in a school district. Okay, so I'm going to go ahead and solve this out. I'm assuming that your algebra is pretty good. So this is going to move over, which becomes negative. So 250 squared gives us -62500 equals -6 delta x. So notice that I combine that and I move that over, which is good because these signs cancel, which means it's moving forward, which is exactly what it's doing in the problem. If you got a negative, something went wrong with your signs. So I'm going to divide that by 6 to solve the problem out. So delta x gives us a value of 10,416 points. I'm going to round 6-7 like that. Okay, good. All right, and now that we have all 3 distances, we can find the total by adding them up. So total will be 625 was the first one. That's where I'm getting that number from. Plus the second distance was 750. Plus the third distance, 10,146.67 meters. And let's go ahead and add those together. We get 11,791.67 meters total, like that. So that was a hefty problem. Not so much that it was super complicated, although you really do need to break it apart. It's just long. So unfortunately, these problems are long. But there's your final answer. So let's move back here to the problem. Let's go ahead and do this. And I believe there's our answer. So you can see where those answers come from. Okay, so that was a more challenging problem. Nothing, I don't think you'll get too much more complicated, but just some advice when it comes to solving more complicated problems. If they don't give you a value, there must be something you can equate somehow. So if they don't give you time, but they give you distance, maybe you can find the distance and velocity to use it for time for later. So that's an example with the 2 cars coming toward each other. There must be something that you can relate together, or there's equal times or something like that. So you can set things equal to each other. Sometimes it's assumptions. Sometimes you need to just make assumptions. Always oversimplify before you overcomplicate. So maybe you didn't get a value for velocity because maybe it was 0. So that's something you can check out too. So just some, minor points for that. But yeah, I hope that was helpful and good luck.